Welcome to another deep dive, and today we're going to be unlocking the mysteries of something that you encounter like every single day, but probably don't think too much about.
And what's that?
Magnets.
Magnets.
And don't worry, we're going way beyond sticking stuff on the fridge.
Okay, good.
Get ready for some serious aha moments.
I like it. I like where this is going.
So, to kick things off, I was reading about this young writer from Kerala, India, named Reshma.
Okay.
And she loves weaving these like fantastical stories.
Mm-hmm.
And in one of them, her characters needed to navigate a stormy sea
Okay.
without stars to guide them.
Right.
So she landed on using a compass, of course, which got me thinking, where did that even come from?
It speaks to humanity's ingenuity, right?
Right.
That long before the sophisticated compasses we have today, people were already harnessing the power of lodestones.
Lodestones.
Yeah.
Those were like the original magnets, right?
It's OG magnets.
Yeah.
Naturally magnetized pieces of iron oxide.
So not something that you just pick up at, like, the
No, you wouldn't find them there. But imagine, right, stumbling upon one of these rocks and realizing, wait a minute, this thing, it consistently aligns itself in a north-south direction.
Right.
It was a revelation.
Yeah.
And that sparked the development of the first navigational compasses.
Wow.
Some dating back thousands of years.
Talk about like old school cool.
Oh, yeah.
So how did we go from those naturally magnetic rocks to the magnets that we have today?
Right.
The ones on our fridge magnets or even inside our phones.
It was a journey of discovery, understanding that it wasn't just about the material itself, iron in the case of lodestones, but also about its internal structure.
Okay.
See, inside every magnet, whether it's natural or artificial, are these invisible regions. Invisible.
Okay.
Called magnetic domains.
Magnetic domains, are those like tiny magnets within the bigger magnet?
You got it. Think of them as miniature compasses, each with their own north and south pole.
Oh, okay.
But here's the thing. In a non-magnetized material, they're all jumbled up. Pointing every which way, just chaos. But when you magnetize something, like turning a piece of iron into a magnet,
right,
you're essentially aligning these domains, making them point in the same direction.
Ah, I see.
This alignment amplifies their magnetic force, making the whole object magnetic.
Okay, so let's unpack that a bit. So when we talk about a magnet having a north and south pole, we're really talking about the combined force of all those tiny domains pointing the same way.
Precisely. And just like with those early compasses, it's this north-south alignment that's key.
Right.
But here's the thing. Magnets don't just attract. They can also repel.
Right. I remember learning about this in school.
Yeah.
Opposites attract. It always felt kind of magical.
It does, doesn't it? But it all comes down to the interaction of those magnetic fields. When you bring two magnets together, their invisible fields, they interact. Okay. If you bring a north pole close to a south pole, those fields, they flow into each other, pulling the magnets together, attraction.
Makes sense.
But if you bring two north poles or two south poles together,
they push away from each other.
They do.
Like they just can't stand each other.
Exactly. It's like they're trying to occupy the same space and they just can't do it.
Right, exactly.
So they push each other away.
So these invisible forces, they're constantly at play, like all around us.
Absolutely, yeah.
Wow.
And what's even more mind-blowing is that these forces aren't stopped by things like wood, cardboard, plastic, or even glass.
What?
Yeah. Remember Reshma's story where her character used a compass?
Yeah.
That compass needle, it's surrounded by the wooden casing.
Right.
But the Earth's magnetic field, it still reaches it.
Oh, wow. You're right. I never thought about it like that. The Earth's magnetic field is strong enough to go right through all that.
It is. And not only that, but the Earth itself, it's like a giant magnet.
Yeah.
Which is what makes those compasses work in the first place.
Oh, right. Yeah.
Deep within the Earth's core, the constant churning of molten iron, it generates electric currents. And whenever you have electricity flowing, it creates a magnetic field.
So that's why a compass needle always points north.
Yes.
It's aligning itself with the Earth's giant magnetic field.
Precisely. Think of it like this. Imagine holding a bar magnet.
Okay.
And you sprinkle iron filings all around it.
Right.
You'd see those filings trace out the lines of the magnetic field.
I've seen that in science class and stuff.
Exactly. Now imagine doing that on a massive scale with the Earth as your magnet.
Whoa.
Those magnetic field lines, they stretch out from the Earth's core into space.
Okay.
Creating what we call the magnetosphere.
Magnetosphere.
Correct.
That sounds kind of intense.
It's a pretty big deal.
Is that what protects us from all those, harmful things from space?
It's a big part of it, yeah. The magnetosphere acts like a shield. Okay.
Deflecting solar wind and cosmic rays that would otherwise bombard our planet.
Right, yeah.
It's essential for life as we know it. Without it, our atmosphere would be stripped away.
Oh, wow.
And the surface of the Earth would be exposed to, harmful radiation.
Wow, I had no idea. Magnets played such a crucial role in our planet's, habitability. It's incredible to think about, those tiny domains inside magnets ultimately connecting to this vast, protective force field surrounding our planet.
It really highlights how interconnected everything is, right?
Totally.
From the smallest atom to the largest planetary bodies, magnetism is a fundamental force shaping our universe.
Speaking of shaping, we've talked about how magnets come in all different, shapes and sizes.
We have, yeah.
But does the shape of a magnet actually impact how strong it is?
That's a great question.
Yeah.
And the answer is a resounding yes.
Okay.
The shape of a magnet directly influences how its magnetic field is distributed and therefore its strength.
Wow.
Let's go back to those iron filings for a moment. Okay, I'm picturing them all lined up around the magnet.
Now imagine a simple bar magnet.
Okay.
Its magnetic field lines are spread out, making it relatively weak.
Right.
But if you take that same bar magnet and you bend it into a horseshoe shape, you're essentially concentrating those field lines.
So by changing the shape, you're focusing the magnetic force.
Exactly. The closer together those magnetic poles are,
Right.
the more concentrated the field lines become and the stronger the magnet. Think about those powerful neodymium magnets.
Okay.
The ones that are super strong for their size.
Right.
They often have a specific shape designed to maximize their magnetic strength.
That's fascinating. It's like magnet engineering.
It really is.
So what about those ring magnets?
Yeah.
What's special about their shape?
Ring magnets are interesting because their magnetic field lines are contained within the ring itself,
Okay.
creating a very different effect. Instead of having distinct north and south poles on opposite ends, the poles are on the flat, circular faces of the ring.
Oh.
This creates a strong magnetic field within the center of the ring, but a much weaker field outside of it.
So it's like the magnetic field is trapped inside the ring.
In a way, yeah.
Yeah.
This makes ring magnets super useful for applications where you want a localized magnetic field,
Okay.
like in speakers or certain types of motors.
Oh, that makes sense. Yeah. So it's each shape has its own magnetic personality, I guess.
That's a great way to put it.
Best suited for different tasks.
Yeah.
It really shows you how much thought goes into designing magnets for, specific purposes.
It's a whole world of engineering and physics. And, we've only scratched the surface today.
Right.
From the earliest compasses, guiding explorers across vast oceans, to the sophisticated magnets used in medical imaging,
Right.
like MRIs. These seemingly simple objects, they've revolutionized our world in countless ways.
It's mind-blowing when you really sit down and think about it. Magnets are involved in everything.
They are.
From generating electricity to even storing data on our computers.
It's true.
They're practically invisible,
Yeah,
but they play such a fundamental role in our modern lives.
absolutely. And the more we learn about magnetism,
Yeah.
the more possibilities open up.
Right.
Researchers are constantly exploring new materials, new configurations, pushing the boundaries of what these forces can do.
Wow.
Who knows what, amazing applications we'll discover in the years to come.
That's so exciting to think about. Wow. Rishma's simple story about a compass really did spark a fascinating journey into the world of magnets. And it just goes to show that curiosity and, a thirst for knowledge can lead to some truly amazing discoveries. So the next time you encounter a magnet, take a moment to appreciate the invisible forces at play and the incredible impact they have on our world. You might be surprised by what you discover.